Hi everybody, this video today is on 10.6. So we have talked about side, 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 and side, angle, side. This time we're talking about angle, angle, side, side, angle, and the Hl theorem, which stands for hypotenuse leg. So first of all, take a few minutes to write these things down. The angle, side, angle congruence says that if two angles in the included side of two triangles are congruent, then the two triangles are congruent. So for instance, we have a diagram here. Remember, we've talked about that phrase included. Included means in between. So this time we have an included side. We have an angle on each side, and then the side in between them is the included angle. So we have angle, side, angle, angle, side, angle. So again, this is just saying that this included side, what I was just talking about, the included side is a side between the two angles. So we have an angle here, and the side is in between. And then we have the angle side congruence, and that is if two angles in a non-included side of two triangles are congruent, then the triangles are congruent. So here we have angle, side, angle, side. This time the side is not in between. So we have had several options so far. We had the two from the other day, side, 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 and side, angle, side. And now we have angle, side, and angle, side, angle. So we've got four that have these three letters in them, and then we have one that has the two letters. Let's practice a little bit on how to find the included side. The included side is the one in between the two angles. So here they're talking about angle A and angle ABD, which is here. And so the question is, where is the included side? Well, the included side is right here. It's side AB because it's in between those two. Let's try another one. Now we're talking about angle C and angle CDB, which is right here. So where would the included side be? It's going to be here, side CD, because it's in between the two angles. And lastly, angle ADB, which is here, and angle ABD, which is here. And where is the side that's in between those two? It's this one. It's BD. So that's what we mean when we talk about the included angle. Okay, so here are our choices on this next section. Side, 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 angle, side, angle, or angle, side, or the Hl theorem, which we haven't actually learned yet, so maybe that's not a choice. But we're going to choose between these four. Is it possible to prove that triangles are congruent? If so, state the postulate or theorem you would use and explain your reasoning. Okay, here we have an angle, another angle, and another angle. So we have two angles. So if we look at our list, it has to be one of the last two. The question is, do we have a side? Where is a side that could be congruent? Remember, I talked about this reflexive side, the one that's like connecting both of them together. So yes, this would be, now if we look at our choices, angle, side, angle, or angle, side, since the side is in between, it is angle, side, angle. Here's my angle, here's my side, here's my angle. All right, how about this next one? Well, once again, we have the side that's in between, so we can say that that's congruent. So we have one side and one angle, but we really need three. Or the Hl, but the Hl, we haven't even learned it yet, and it's not here. So this is actually no, there's not enough information. This does not work. Next problem, we have this angle and this angle, this side and this side. Do we have anything else? We have to find something else. We have this one, the angles that are across from each other. Those are called vertical angles. So yes, we do have three things now. The question is, are they angle, side, angle, or angle, side? Well, is that side in between? No, it's not. So it must be angle, side. So I'm going to kind of show you in order of how that goes. Here's an angle, here's an angle, here's the side. It's not in between, it's over here. All right, on this one, once again, we have an angle, another angle, and we have the vertical angles that we talk about. Now, we have three things, so good, but they're angle, and angle. They're all angles. They might not be congruent. If they're not all, if we don't have a side, we have to have at least one side. So no, not enough information here. All right, once again, we have this side in between here, this shared side, this reflexive side, but we do not have any angles. We only have two things. We need to have at least three things, not enough information. Let's turn the page. All right, on this page, we're going to be dealing with some proofs. I want to put my bars above my segments. Sometimes I forget those. All right, I have some givens filled in, and I have my proof statement filled in, so you take a second to do that. Now let's take a look at what we have going on in the diagram. Do you see this little triangle? That means they're parallel, because look, this says they're parallel. Does not say they're congruent, it says they're parallel. What does parallel mean? Well, it means that these two lines are like these big, long parallel lines that go on forever and ever and ever. And we have a transversal cutting through there. Okay, so that's important for us to know. Before we just jump into that, maybe we can take a look at what else we know so far. So we know that BD is congruent to BC because that's given, and that's shown here. We need to find an angle. Well, one angle I can definitely see is I have this angle, right? Those are vertical angles. And so now thinking about our options, let me list our options for us again. Here are the four options: side, 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 angle, side, angle, side, angle, and angle, angle, side. We have an angle, we have a side, we need to find something else, and it needs to be in the right order. Okay, well, what should that be? Well, there's nothing congruent. We have to go with an angle because there's not enough to say that they're congruent. But since we do know that these are parallel, we have a couple of different choices on our angles. Because as I look at this, really either one of these could be considered a transversal. I'm just going to mark this one, but really they could be the other one as well. And now we need to look for things like alternate interior angles, something like that. So for instance, I see alternate interior angles here, right? So we can say that angle A is congruent to angle E. And the reason, alternate interior angles. Now I did that because this was a parallel statement. This one says parallel, and so that means I need to look at this transversal. And I need to go back and remember congruent and what's supplementary and alternate interior, alternate exterior, all that. But this is alternate interior, and so they are congruent. Then we are given that angle B is congruent to angle C. Now, is this angle side angle or is it angle angle side? Well, is the side in between? No, it's not. It must be angle angle side. Now, I didn't realize I left something out. What have I left out? Well, this angle in the middle. I talked about it and I marked it, but I forgot to write it down. We cannot just call it angle B because angle B, that one letter, doesn't give us enough information. We have to give it its full name. How about angle ABD is congruent to angle EBC? Right? You have to give 3 letters because otherwise you don't know which part of the angle you're talking about. And why are those congruent? Because they are vertical angles. All right, let's take a look at another one. All right, once again, I have this filled in with the givens, so take a minute to fill this in, and then let's talk about it. Okay, the 2 givens, let's go ahead and mark those because I just feel like when you mark them, they're easier to see. So angle B is congruent to angle C, and angle D is congruent to angle F. So those are congruent. Now we have this thing that says M is the midpoint of DF. We're talking about right here. Here's M, and we're saying it's the midpoint of this segment. If it is the midpoint, that means it divides it perfectly in half. So that means we could say that DM is congruent to MF. Why is it we can say that? Well, because you told us it was the midpoint. And if it's the midpoint, then they're congruent. That's a definition of a midpoint. And finally, we have the triangles. BDM is congruent to CFM. What theorem is it? Side, 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 angle, or angle, angle, side. Well, let's take a look. What do we have? We have an angle here, an angle here, a side here. Is the side in between? No, it's not. So it's angle, angle, side. This last one on this page, we're going to leave this for in class. So I marked it out, but don't cross it out entirely. We will do it in class. But we do need to turn the page because there's one on the back. All right, on the back, this is the theorem that I've mentioned, but we haven't actually talked about it yet. It is the HL theorem. HL stands for hypotenuse leg. So what it says is if one leg and the hypotenuse of 2 triangles are congruent, then the triangles are congruent. Well, to do this, to understand this, you have to remember what is a hypotenuse and what is a leg. So the hypotenuse is the one that's across from the right angle. So remember that this little symbol here, that means right angle. And so the one across from that is the hypotenuse. If I label my triangle, I'm going to call this ABC, for instance. Okay, then in this case, my hypotenuse is side AB. It's the one that's across from the right angle. Then the legs are the other two, the ones that create the right angle. So BC and CA are the right angles, BC and CA, because they make up the right angle. They create it, so that's the legs. I wanted to show you what this looks like as a diagram. So here are two diagrams, so you kind of know what to look for. It's two right triangles. They could be pointing the same way, they could be different ways, they can be whatever. But notice one of them is marked with a hypotenuse, the other one is marking a leg, and they're both right triangles. Same thing here, but just a different one. We've got a different leg marked. So this time the hypotenuse and the leg and the right angle, the hypotenuse, the leg, and the right angle. That is the HL theorem. That's the only one that doesn't require three parts, because all the other ones, angle, side, side, etc., they all have three. This one only has two. I guess you could say it's three because it's the angle, also the right angle. You could consider that the right angle. Okay, now this is our last proof. So once again, I have filled in all of the given information, and we need to work with it. So take a second to write all that down, and then let's see where to go from here. Okay, they tell us that this is a right angle, it's marked. This is a right triangle, and the other one is a right triangle also, it's marked. AC is marked, DB is marked. Can you see that that is the hypotenuse because it's across from the right angle, and this one is also the hypotenuse because it is across from the right angle? What we need to do is say, if this is going to be the HL theorem, which it is because it's a right triangle, so if it's going to be the HL theorem, well, we already have the H, we need a leg. Which leg could we get? Well, remember this one that we keep coming back to, the one that's like shared in between there, that shared side, I'm calling it that reflexive side, that is BC is congruent to BC. And if we say something is congruent to itself, that's called the reflexive property. And so now what do we have? Those two triangles, we have a hypotenuse and a leg. This is the HL theorem. All right, the one we skipped, we will come back to in class.